Good evening, everyone. I believe you all can hear me. If you can hear me, can you type on the comment section that you can hear me and confirm if you can also see my screen. If you can hear me, type on the comment section. If you can see my screen, also type on the comment section. Okay. For those of you who are unable to type on the comment section, the comment section is you can send message if you're a subscriber to the channel. So those of you that haven't subscribed, please hit the subscribe button so that in our next class you'll be able to ask questions and also have access to the chat box. Okay, so one person is online, somebody called Anonymous Troops. So who else is online? If you can hear me, I would like you to type on the comment section, drop the comments on the comment section. You can hear me. Do we have only one person on this call? We're supposed to have a lot of persons, about 6 persons are online. Okay, so we are supposed to start this class by 8:30. 8:30. We're already 4 minutes behind, and I'm going to start now. So first of all, I'm going to introduce myself, and my name is Prince Christopher, and I'm a CAD designer, also a project planner, and also specialize in process simulation using Hysys. I graduated from FUTO, and I'm also the Chief Executive Officer of and the Managing Director of Royal Grand Engineering Trainings, which is REnT. And I and some of my, will I call it course mates or classmates, we decided to organize this 2 days free class on Aspen Hysys. Um, the truth is, when you leave the university, what the university gives to you is not what the industry demands. I was speaking with my colleague today in the office, and we decided he studied petrochemical engineering. So we decided to look at what we were taught in university and also look at how it's been applied in the industry. We find out that everything we learned, especially from 300 level up to 500 level, like those things can be summarized and taught in 1 year. There are people they call, yeah, there are people they call in trainee engineers, and there are also those uh, that are not graduates, but they know the techniques, they know the job more than the graduates. Why? There's what they call learning on the job. You might not be a graduate, you might not study chemical engineering, you might not study civil engineering, but following someone who is an expert, you get going to site, you definitely know what that profession is all about. So we sat down and looked at the course curriculum. Let's use chemical engineering. Yes, I studied chemical engineering, FUTO. Study chemical engineering, FUTO. separation process, transport mechanism, everything you learn, you can learn it in the industry, even in 6 months. In 6 months, you can learn all those stuff. And the painful part is the bulk of chemical engineering, which we are supposed to be taught before leaving the university. We are not taught those stuff. Those of you that are in chemical engineering now, have you seen a heat exchanger before? You haven't. Have you seen a separator before? You haven't. Just theory. I was asking an employer, and I asked him, why is it that you won't want to pick a graduate? What this person is a graduate, he has gone to school. He said, you being a graduate does not mean you are employable. For you to be employable, it means you need to have the required skill that is necessary to fit into that job. And that is what this training is all about. It's not an in-depth training, but this is what the university is supposed to provide for you. Throughout my stay in FUTO, from beginning to the end, we didn't use Hysys. In fact, some of us that learned it during 400 level IT period, there was no lecturer in chemical engineering FUTO that knows how to use Hysys very well. And Hysys is one of, in fact, when you leave the university, those of you that will be in the oil and gas sector, what you'll be called is process engineer. You'll be called a process engineer. You are not, nobody will call you chemical engineer. And that stuff that you have always been told, the moment you finish chemical engineering, you can work anywhere. That thing is big lie. You. As a chemical engineer, one day will not pick you and throw you inside civil engineering. You have to come out as a chemical engineer, go for your NYSC, go for your, you can go for a training as a process engineer, or you go for graduate training, you enter a company through graduate training. The reason the company is taking you is because they want to train you to get the skills that is required for you to work adequately as a process engineer. So you have to come in as and start as a graduate trainee, then junior engineer, you scale up the ladder like that. So Aspen Hysys is one of the major tools we use in as a process engineer. You use Aspen Hysys for your separator sizing, you use it for your line sizing, you use it in carrying out optimization. So you have a feed, you have your feedstock, and you have your results or your product. Your products, you want to get 90% methanol from whatever your feedstock is giving you, or your natural gas, whatever it is. And what you are getting is 80%. For those of you that are 400 level or 500 level, you should understand what I'm saying better. What your feedstock, you want to get 90% or 95% methanol or methane or whatever you want to get. But when you run your simulation through Hysys, you are getting it, let's say 0.8 mole fraction. Now, with Hysys, you could run case study, you could carry out case study. Okay, if I'm getting 0.8 mole fraction of ethane or methanol, now at what can I vary in my whole process in this flow sheet that can give me 90% or something greater than 80%? Should I increase my pressure? Should I increase my temperature? What should I do? In what area? So in Hysys, you could carry out all those. You could also carry out hydraulics. This is for if you are carrying out a simulation on your pipe. You could also size your heat exchanger. You could also size your pump. everything that is required in the field. In fact, in the oil and gas sector, the process engineer is the number one man because every other discipline is dependent on you. The mechanical engineer that needs to rate the pump is waiting for the process engineer to give him the data. So we need to first of all carry out the basic sizing of our pump. For instance, we tell the mechanical engineer, okay, we need a pump that can produce 11 kVA of power. And the mechanical engineer will be like, okay, they they have those data, they get through procurement, procure a pump, a pump that requires this amount of energy or power. Yeah. The same thing applies to every other, maybe your heat exchanger that needs to be procured. Your separator also, you could also size your separator to know the number of stages inside the separator. You size it to know the diameter, to know the height, the number of packings, all those stuff. Everything can be done in Hysys. Nobody is going to tell you to use McCabe theory, to use Fuscaf to do any calculation. Whatever you are doing, there's a software for that. You understand? So I want to use this time to explain few things that most of us have gotten wrong. And I believe the president took out time to carry out publicity concerning this. One thing that the school system has done us is to close our eyes. Sometimes when we see opportunities, we tend to miss it. We feel uh, you just need to read, come out with second class upper, first class, and that's it. That's a lie. That's a lie. Next day we are opening a podcast where we are going to interview a lot of process engineers. Let them tell young engineers like you how they got into the um into the system. What are the things they passed through? How did they start? How did they end? What were the challenges? For instance, rent, we charge 100 each someone as spend Hysys, as it has to do with process engineering. Now, Aspen Hysys can be used in the pharmaceutical industry. Aspen Hysys can be used in different area, in petrochemical. But for this training, what we are going to focus more on the oil and gas. You understand? Okay. So as I continue, if you have questions, I would like you to drop it in the chat box. Also, please tell your friend that they don't need to miss this training session on Aspen Hysys. So this knowledge people are getting for free, people are actually paying a huge amount for it. Yeah, people are paying a huge amount for this. Now and there's a lot. For those of you that are chemical engineering now, I would like you to start making plans to join SPE, Society of Petroleum Engineers. Chemical engineering don't really have an active body like that. I think for joining SP is cheap or affordable or free. I don't know. But the moment you leave the university, you want to join SP as a graduate member, you'll be paying about 65,000 naira to join. And the reason I'm saying this is for networking. This class is not it's not like your normal class where it's either it's this way or it's not this way. When you get into the industry, everything is open book. You want to do your flare sizing, they are standard for it. You use your API codes and for all those stuff. So the way it's being done in the industry and the way you are being taught are two different things. There's nothing like close your book, let this person not copy for you. It's basically teamwork. You want to do this, you want to size separator. There are standard, and each company you work with as a process engineer, it varies, it changes. The standard for mobile is not going to be the same standard with NLNG. The standard Chevron is going to use is not the same standard um, Schlumberger is going to use. You get. Okay, I think I have said one or two basic things I need to say because it's more like me talking to my younger self when I was in school in FUTO. So all the you need to learn how to use AutoCAD. You need to learn how to use Aspen Hysys. You need to learn how to use Excel, Microsoft Excel. These are three key softwares you need to know how to use as a process engineer. Very, very important. And don't carry book too much in your head. Go and learn a skill. Skills will open doors faster than that your second class offer you're looking for. Don't say I did not tell you. Skills will open doors for you. Okay, so let's go back to the topic for today, which is Aspen Hysys. So Aspen is an acronym for Advanced System for Process Engineering. It is a it is based on a flow sheet simulation. Um, so basically, when you hear about Aspen Hysys, just know that the principle of Aspen Hysys is flow sheet simulation. Then, what is flow sheet simulation? Flow sheet simulation is a computer software that is used to quantitatively model a chemical processing plant, which, in addition to core reactor units, also include pre and post treatment steps. So, a flow sheet, let's define flow sheet first. A flow sheet is simply the steps that is involved in a process. So if in people that are into software engineering, before you develop your software, you also need to develop a flow sheet. A flow sheet is simply a diagrammatical process on how you solve a problem from the start to finish. So in process engineering, your feed, how it moves from the start point, the inlet, up till the exit, where you get your final product. Chemical engineering, Aspen Hysys models that. So that's why you have your PFD, which is your process flow diagram. So that chemical process, the flow from the input to the output, that's simply what a flow sheet is. And there are different type of flow sheets. You have your PFD, we have P&ID, we have utility flow diagram, which is UFD, and there are a lot of them. They have BFD, which is block flow diagram. So CH202 or 204, I think people are supposed to be introduced to process flow diagram and all of that. Okay. Um, so simulation of an entire chemical process starting from the raw material up to its finished product is symbolically represented by different icons, where each icon stands for a unit operation. Okay, I would like to ask, you are chemical engineering, what's the difference between a unit operation and a unit process? I would like you all to drop your answers in the comment section. Unit operation and unit process. What's the difference? Okay. Um, which each icon stands for a unit operation, chemical process, input and output stream, input and output energy stream, input and output electric signal. Aspen Hysys flow sheet enables us to run many tasks, which is conduct if what if test. And this can be seen in your PSV, which is process safety valves, when you are developing that's under safety, you want to run different scenarios on how your PSV is going to run. There are different scenarios there in terms of increase in temperature, increase in pressure, fire outbreak, what if tests. You can carry out all those tests. You can also carry out design specification. Now, when we are saying design specification, your separator, what is the specification? What was its sizing? You get. So we are actually looking at its sizing. You could also carry out bottlenecking of constricting parts of the process. You could also carry out sensitivity analysis. If you are using Aspen Plus calls it sensitivity analysis. Aspen Hysys calls it case study, just like what I explained. Um, we want to get 90% purity of methanol, but we got 80%. Sensitivity analysis will carry out different, case study, yeah, different iteration on what pressure can we get 90%, or we could vary temperature and pressure, to see which of these can give us a higher yield. You could also carry out optimization investigation. And when we are saying we are optimizing our plant, basically, when we when process engineering is basically business. So you are getting your feed, processing it so that you get a finished product, sell it, and make profit. So when we want to optimize this system, let's assume we were getting 50% purity. Now we want to optimize this process so that we can get maybe 70%. The more pure um, our finished product is, the more profit we get. So the more reputable our firm is. So if you are going to buy gold, one person's gold is, let's assume 90%. Okay, so let's assume you want to buy gold. We have two sellers. The first person you wanted to purchase gold from, this person gold is 80% pure. And there's another seller that wants to sell this gold to you, and his own gold is 95% pure. Which of them are you going to buy from? Definitely the one that has pure gold, the purer gold. Or let's now assume you have the third person, and this person's gold is 99% pure. So you see that the rate of your how pure your finished product is how fast your market is going to sell. So with analysis process simulation, we can design better plants and increase profitability in existing plants, which is basically what I said. And increasing profitability also has to do with your waste products. Now, NLNG, all these oil producing plants, some of the waste products, some of the gases, some of the waste product they get is what they use in generating, it's being recycled and used as energy or source of power for the plant. So if instead of flaring a gas, you could use that gas as a source of energy to power a gas turbine. You see? So let's say crude oil to the same thing. You are refining to get fuel, but during the process of refining, you get kerosene, you get diesel. You could now buy a diesel engine. You get so your diesel is not what you want, but you could use it to power your plant. So this is where Hysys come into play. You could do all this. So if your plant is self-sufficient, that's why you see some of most all oil and gas company, they provide their energy themselves. They don't rely on NEPA because some of the waste product or some of the byproducts is being used to power the facility. So we can translate a process into Aspen Hysys, not Aspen Plus, process simulation by carrying out the following steps. So in order for you to carry out a simulation in Aspen Hysys, there are different steps you need to follow. The first is to specify the chemical component in the process. And how do you do that? You could fetch that from the Aspen Hysys data bank. Um, just give me a minute. I want to share my Aspen Hysys screen. Okay, someone said unit operation typically involves physical, like filtration. Yeah. Unit process is a chemical change. Yeah. So yeah, you guys are correct. Okay, so this is my Aspen Hysys. This is something I was working on, and this is a gas processing plant. Um, so in order for you to start doing this, the first thing you need to do is to specify the chemical component that is involved in this process. And this is, we have component list here. So you can see nitrogen, CO2, methane, ethane, propane, iobutane, n-butane, isobutane, and normal butane. So this is where you, first of all, get your components. And we are going to look at all this more in our next class tomorrow. How to add your components, how to specify the rest. So you need to first of all come here, and Aspen Hysys has data bank of a lot of components. So if you scroll down, I'm scrolling down, you can see 3M hexane, E, all these are components. There are thousands of components in Aspen Hysys data bank. There are a lot of them. And one good thing is if you don't find those components, you could also specify your own components. So let's assume there's a compound you want to use, but you can't find that compound or element here. With the properties of that element, you could define your own custom-made element in Aspen Hysys, which when you click on hypothetical components, so from here you can specify the initial volume for all these are something for some other class sometime, not even in this class. I'm just giving you that insight. So the next thing you need to do is to specify the thermodynamic property of the components you want to use. Back to my slide. So specify the thermodynamic property of the component or mixture you want to use. These models are also inbuilt into Aspen Hysys. Then the next thing, the third process is for you to define the unit operation in the process. So you could see different stuff. So when I say define the unit operation, you need to specify your feed stream. That's your material stream. You specify if there's a heater there, if there's a mixer, if there's a splitter, if there's a separator, if there is a cooler, whatever, you specify all those stuffs. Then you can now label each block, label each unit operation model as part of the process. You specify the component flow and the thermodynamic condition. So when we are talking about thermodynamic condition, we are looking at temperature, pressure, and composition, flow rate of the feed stream. The next thing we need to do is to specify the operating conditions for each unit block. If you have any question, please drop it in the comment section. Okay, application of process simulation. Process simulation is a tool for process and chemical engineers. You see, process. So when you get into the oil and gas, you'll be hearing more of process engineer, senior process engineer, this process engineer, and little of chemical engineers. Yeah, process and chemical engineers that can be used in the execution of repetitive tasks or in activity of high complexity that must be solved in a relatively short time. The various application of process engineers, one, make a better use of energy resources, just like I mentioned earlier that all oil and gas companies produce their power themselves. Why? Because they make better use of the energy resources. They minimize operating costs. All these I have explained them before. Increasing yield and process efficiency, I've also mentioned it before. Increase the process controllability, propelling teaching of process engineering design, just like what you are participating in now. So there are different file types. All these, I'm not going to bulk you with that. Okay, so when you set up Aspen Hysys, the first thing you need to do is to set up your description, title, purpose of the job, specify your component, the measurement units you want to use, the components you also want to use, physical and thermodynamic property, choosing your block. So before we go into the actual simulation, there is one major aspect of Hysys you need to understand. And you need to understand it at your fingertip, which is property model. If you use the wrong property model, your simulation is automatically going to be wrong. If you are using Penn-Robinson when you are supposed to be using Wilson, your simulation is automatically wrong. A thermodynamic model is a set of equations that permit the estimation of pure components and mixture properties. In order to represent chemical processes, their modification, equipment, new designs, the selection of a thermodynamic model that represents accurately the physical properties of the substances interacting in such process is mandatory. Please, I would like you to note this. I would like you to note this. The selection of a thermodynamic model that accurately represents the physical properties of substances interacting is mandatory. Now, you agree with me that the way water, the physical properties and the chemical properties of water, H2O, is not the same as sodium hydroxide, is not the same as crude. So if you are modeling crude, you are not going to use the same thermodynamic property when you are working with acidic substances. You understand? So you need to know the correct thermodynamic property to use. When you are using your feed has a certain pressure, it also affects the thermodynamic property you are going to use, which we are going to look at. There are four thermodynamic models available. We have the ideal model, we have the activity coefficient model, we have equation of state, we have the special method. I'm going to share another slide. Okay, so if the resolution is blocked from your end, what you need to do is there's a settings, a gear icon on your phone. All you just need to do is to click on it. Your network is poor, so YouTube has automatically stepped down the resolution for you. Same thing applies when you're watching a YouTube video. You get where you increase your resolution, you can also increase it during a live stream. Okay, I believe we are all good. Okay, just give me a minute. I want to share uh, a document. Okay, so this is, I want to explain the different um, thermodynamic models we have. I said we have the ideal, activity coefficient, equation of state, and special method. So of the first we are going to look at is the equation of state. The equation of state is best suited for hydrocarbons and gas processing. So and this is what is basically used in the oil and gas sector often. So whenever you are working or the components, your feedstock is gas processing, you use Pengrobinson or SRK, Schwab Relish one. Now it is widely used in the oil and gas. It handles vapor liquid equilibria well um, for natural gas, crude oil refinery, and petrochemicals. So when you are working with petrochemical, you have looked at the components, and you know that the components, for instance, you are saying methane, ethane, embutane, you just know that these are hydrocarbons. You understand? So what comes into your mind is that I'm either using SRK or Pengrobinson. Now, if what you are working with is um, high, heavy hydrocarbons, Pengrobinson is the best. If you are working with um, light hydrocarbons, SRK is the best. So SRK, similar to um, PR, which is Penn Robinson, is better for light hydrocarbons, common in gas processing, dehydration, sweetening, cryogenic. So whenever you are doing dehydration, carrying out dehydration simulation, sweetening, just know that, okay, I'm supposed to use SRK, or I can use, sometimes your client, the client you are working with, or the company might specify the equation of state model you can use. So, like I said, it is less accurate for heavy hydrocarbons. We also have PRSV, which is Per Robinson's Triject Vera, modification of PR with better accuracy for polar and associating compounds. We also have activity coefficient models. Okay, so we also have activity coefficient models. It is used for non-liquid systems, non-ideal liquid system. And we have example, we have polar, we have electrolytes, we have hydrogen bonding systems. So for those of you that like, okay, what this guy is saying, when we are talking about um, okay, non-ideal liquid systems, I'm coming, I want to pop up something. So for non-ideal liquid system, these are non-ideal liquid system are mixtures where molecules interact. Molecules interaction differ from their pure state, causing deviation and resulting in a non-zero heat volume change upon mixing. So for that, we have polar electrolyte hydrogen bonding. We have NRET, which is non-random to liquid. It's good for polar mixtures. It's good for azeotropes and solvents. And this is common in chemicals, pharmaceutical, and special chemical industry. When you are working with a pharmaceutical company, or the simulation you want to carry out is something that has to do with pharmaceutical, special chemicals, azeotropes, just know that you are using NRT. Okay, we also have Uniquark, which handles highly non-ideal mixtures and electrolyte solution, useful in separation processes, treating liquid. So we have the first one good for polar mixtures. Uniquark is good for non-ideal mixtures. We also have Wilson. Wilson is suitable for non-ideal system without miscibility gap. Good for binary and multi-component mixture. So we also have special properties, specialized property packages. And we have glycol property package for dehydrating systems. We have amine package. We have electrolytes. We have PRV plus CPA, which is cubic plus association. We also have generalized models, which is ideal property package. So this assumes ideal gas and ideal liquid behavior. So in summary, when we are working with natural gas, crude oil, refinery, what do? We use Penn Robinson or SRK. If we are working with gas processing, And gas processing has to do with NLNG, liquefied natural gas, dehydration. You still use SRK or Pen Robinson. If you are working with amine sweetening, you use amine package. Glycol, you use glycol package. Electrolyte, acid, salt, you use electrolyte NRLT. If we are working with polar and azeotropic systems, e.g., ethanol, water, acetone, water, what do? You use NRT, Uniquark, or Wilson. Then simple non-polar gases, we use Lekesla blocker. Okay, so don't know if there are questions. I'm just going to check. Someone asks if this class is recorded. Yes, it's on YouTube. YouTube records all the classes. So after this class, I'm going to send out the link where those of you that don't understand something or you want to watch it again, you can always go back and watch it. So in today's class, what you are going to do, we are just going to introduce Aspen Hysys, the interface, and some of the theoretical jargons I have said. Let me share my Aspen Hysys screen. So when you open your Aspen Hysys for the first time, basically this is what you're supposed to see something like this. Although you're supposed to see a blank screen, yeah, where you can click on new. But I want to start from resources. So from the top, we have our ribbon, which contains different tool sets. And after our ribbon, we have our tools bar. We also have our title bar at the top, which shows us the title of the drawing we are working with. For this, we can see gas processing tutorial. You can see gas processing tutorial. So the first is what's new. When you click on it, Aspen Hysys is going to tell you the changes. I'm using Aspen Hysys V11 version 11. So from here, you can see it's being categorized. We have general Hysys improvements. We have Hysys property improvements. We also have Aspen Hysys dynamics, safety improvements, and all of that. So from this, you can see the changes they made. From here, you could see one of the improvements. It said reduced memory limitations for very large complex flow sheets or sub flow sheet. For example, equation oriented object flow sheet. So the next one we have is examples. Aspen Hysys has predefined examples, already solved simulation. So if you want to look at a simulation on, for instance, maybe pressure relief system, yeah, you can just double click on it. You can see different simulations that Aspen itself as a company has already done, and it comes with the installation file. So you can click on any of these and open it. We also have training, but for training, we can't access it. This is just this is for those who are using the licensed version. So with this, you can access all Aspen Hysys free training materials and both PDF, video, audio. We also have documentations also, but all these are for those that are using the licensed version of Hysys. Okay. Then we also have events, announcements, all content. All these, most of them are available for those that are using the paid version. So when I click on file, this opens up from here, recent model. We can see previous simulation that has been carried out with Aspen Hysys. The first thing we have is new, is to create new. Open is to open previously saved documents. I'm going to click on new. So we have case, we have templates, we have columns, we have FCC, fluidized catalytic cracker, we have hydrogen cracker, we have reformer, we have sulfur recovery unit, we have compressor purge systems. Whichever one you want to use, if you are working on FCC, reformers, whatever. So for this, we are going to click on new case, a blank workspace. Here we carry out our simulation. Okay, just give it some time. It's taking time to load spots. So while you are in this class, I also like you to drop a like to like this particular live stream. Okay, so let's come here. This is the workspace of Aspen Hysys. When you create your first case, and when you do this, this is what you are going to see: a blank screen. And by my left, you can see component list, you can see fluid package, you see petroleum, assay, reaction, component map, user property. The two major things we are interested is component list and fluid package. I'm going to go back to my slide because there are a few things I mentioned. I'm going to share my slide this time. Now, Aspen Hysys process simulation model. I said we can translate a process into Aspen plus Aspen Hysys process simulation model by performing the following. One, specify the components in the process. Two, specify the thermodynamic property. That's what I want to explain now, how we do that. So from here, you can see by my left, component list, and we have an icon which can see a circle, and half of it is white, half of it is red. What it means is that there's an error or a warning sign that we haven't specified some parameters in that. So in order for us to specify our components, we come here and click on add. From here, I told you that Aspen Hysys has a lot of components in its database. There are a few ways of specifying the component. If we want to add water as the component, what I need to come here do is type water on the search bar. And you can see water. That's the simulation. You can see the simulation name H2O. You can see the full name. You can also see the formula H2O. Now, if I don't want to use water as a word, I can also type H2O. And it's going to bring that for me, pure components. So what I need to do now is to click on water. Now, whichever one I click on add, you are going to see it here. It's going to appear on my left. I can add methane, see it here on my left. Can add ethane. Some other thing I can do, I can replace. So if I want to replace ethane with some other components, maybe nitrogen, I'll click on replace. It automatically removes it. Ethane is now here. I'm going to do that again. See, ethane is here. I'll click on replace. Then I can type N2, which is for nitrogen, and add nitrogen here. I can also add more than one component at a time. So what I need to do, if I want to add more than one component, let me use H2O again. So if I want to add all this component that has water, I'll click the first one, hold down the shift key, click on the last one. click, click, then click on add. I can see that I have added all those components. Next thing I'm going to inform you about is the message dialog box at the bottom. The message dialog box gives you warning. So if there's something wrong in your simulation, you are going to know that with the message dialog box. Now it says required information, fluid package. I need to select the required fluid package. And also by my left, I can see fluid package with a warning sign. You get component list. The moment we select our component, you can see a check mark. A check mark has replaced the initial warning sign, meaning my component list is good to go. I'll click on fluid package. So for this, what I'm going to do, I'll select all these and remove them. I'm going to use hydrocarbons for this. So I'm using hydrocarbons, then I'll select on my fluid package. Select on my fluid package. Now, sometimes you might not know the correct fluid package to use. What do you do in such case if you don't know the correct fluid package to use? What do you do at that point in time? So what we need to do is to use the property method assistant. So while you're on this live stream, I would like you to like this. I would like you to drop a like what? The like button or what? Yeah, just like this session. Okay, yeah, there's what we call fluid package. It's at the top. Click on it. Click on method assistance rather. When you click on method assistance, you are going to see this dialog box is going to pop up. Now, let's move together. As when Hysys property package selection assistance. Say, welcome to this. The purpose of this assistance is to help you select the most appropriate property package for use with Aspen Hysys. The assistant will ask you a number of questions on your response. Based on your response, it will suggest the one or more property packages. Now, it has categorized it. We have oil and gas, we have refining, we have chemicals, we have clean fuel, we have electrolytes, we have environmental, mineral, and metallurgical, we have chemical, we have power. Let's look at electrolytes. Now, under electrolytes, it says use OLI electrolyte for aqueous. Use Aspen property electrolyte method for aqueous solution. You see, for refining, it gave us three solutions. One, Pen Robinson. Two, second one is rank K10, Kayo Cedar, Grayson Trade. Now you say you can also use cubic equation of states, such as CPA, which is cubic something, we looked at that. Then SRK. Remember, I said if you are using if the components or what you are simulating has to do with oil and gas, either use Pen Robinson, SRK, or CPA. Now, our property assistant or method assistant is also stressing some things. He said if system contains hydrogen, use Pen Robinson, Grayson Street. Now, if you also come down, is also going to give you more assistance. Now, I said to model soil water stripping, we recommend you use soil water package. But whatever you are doing, you are also going to see that it is revolving around Pen Robinson, SRK, or CPA. Now, it says select one of the following for further assistance. What we selected, they are all gases. So I can say gas treatment. So it says select the gas treatment we want to use. So whichever one we want to use, no, this is not what we want. So I'm going to come down and select refinery. So you can see all different types of refinery process under FCC. We could also use assay. So, but what we are simulating, our base peak is Pen Robinson. Now, I'll click on Pen Robinson. Under Pen Robinson is going to give us some other information why we are using Pen Robinson. Now, under Pen Robinson model is ideal for vapor liquid equilibrium, which is VLE. Calculations for hydrocarbon system, you can see, very good. Now, under this, there are further reasons why you should use Pen Robinson. If the temperature range is greater than minus 271 degrees centigrade and pressure range is less than 100,000 kPa, which is kilo Pascal, or 15,000 PCIA, you are going to use Pen Robinson. So with this, you can, it also gives us other areas where we could use Pen Robinson. So Pen Robinson PR can also be used in tea, tech, dehydration. From this, the Pen Robinson property package can also be used for, these are the simulations you can use it for: cryogenic gas procession, air separation, atmospheric crude towers, vacuum, reservoir systems, crude systems, ethanol injection, mercury, NLNG processes. There are a lot of them. So let's go back. Um, let's click on oil and gas processing. So under oil and gas processing, we still have Pen Robinson because it has hydrocarbons and hydrocarbons are involved. So that's basically it. If you are lost, you don't know the right property package to use, you just need to click on your method assistant and you are good to go. So for this, I'm going to use Pen Robinson. Yeah. Now my message session, I don't have any warning. I don't have no warning, nothing. I'm going to switch back to my simulation. So in our next class tomorrow, we are going to run a lot of simulation. You get maybe 2, 3 simulation, 2, 3, yeah, maybe 2, 3 simulation. So this is your flow sheet environment where you add your material stream, you add the components you want to use, you add your separator and do all your manipulation and all of that. So you do all that here. Now under my message section, you can see that it's giving me warning. It says required information for V100, which is my separator, my two-way separator. It says required information for product stream. This is a two-way separator, so it needs two streams needs to be specified. It also needs an input stream, which is the feed stream for this. Now, if I double click on this and select my feed stream, now the feed error has gone off. What is now required is products and another product stream. Okay, so this is where this is my model palette here. This is the model palette. It contains the informations necessary or the process units necessary to carry out your simulation. So you can either pick or you search for them. You can type heater and you can see different type of heater. This is the furnace. You can type cooler. You can type separator. You have different type of separator. You can type mixer and what have you. Just select all of them and you can also set them also by category. We have separators. When you click on separator, you're going to see all the separators listed here. You can also click on your distillation column, absorber, reflux absorber, reboiler, what have you. They are all here. You have 3-phase separator, you have 2-phase separator, you have your tank. You can carry out all those simulation. We have your reactors, your CS, continuous state tank reactor, which is CSTR. You also have your PFR, which is plug flow reactor. You also have your conversion reactor, the equilibrium reactor, Gibbs reactor, the yield shift reactor, and all of that. So all those stuff you have been learning in chemical engineering and solving a lot of stuff. You just need to click 2 or 3 buttons and you have solved all those stuffs. So please, if you have questions, I would like you to ask. Okay, let me check how many persons are tuned into. I told your president that if we don't get in a good number of persons that attend this class, tomorrow's class is not going to hold. So for today's class, we have 14 likes. Okay, that's good. And how many persons are live? 52 persons. Okay, that's also good. So tomorrow's class is going to hold. Just give me a minute. Okay, back to Hysys. Okay, so we have pressure changers. Under pressure changers, we have your pump, we have valve, we have your relief valve, which is pressure relief valve, PRV. We also have compressor, we also have expanders. We also have piping and hydraulics. Under piping, we have mixers, T, pipe segments, and all of that. Okay, so thank you all for participating in today's class. But before we end today's class, I want to, introduce you guys to safety analysis. So safety analysis is directly under your simulation. So safety analysis is basically where you carry out safety simulation on your process, which is where you start adding your PSV, which is your pressure safety valves, basically for safety. And process engineering is actually broad. There's the aspect of commissioning, there's the aspect of process safety, there's the detailed engineering design, there's equipment, there's also the simulation aspects, which you can be called a simulation engineer using Hysys and maybe Flow Sim, Auger, Pipe Sim, and some other softwares that are out there. So you could also carry out safety simulations in Hysys also. So thank you all for participating. At this point in time, I'm going to entertain questions. Please drop questions. I need a lot of questions from you guys. Please ask your questions so that we can call it a day. But how many persons are still online? So I hope you got something from today's class. You understood something. Please, I would like to get your response. So I hope you learned something today. Okay, the highest number of participants we had was 15. The lowest we had was 2. Okay, so for those of you that attended today's class, please tell your colleagues or your classmates tomorrow to participate. It seems like it's only person speaks that is online. No other person is online again. Currently, I have just 6 persons online. Very poor. Okay, so in tomorrow's class, we are going to carry out few simulations, real world simulations. Okay. Thank you all for participating, and we'll see tomorrow, same time, 8:30 p.m.